Hello, this is Yarrow. Today is the 23rd of February 2018. Doing a follow-up to the Ron Cole video of last week on Valentine's Day, and this one is a little bit more detailed about the differences between the Cole version and the ZFM. ZFM was the original. In any case, let's just go through a couple of little basics here, and we'll just continue to elaborate. The original Zero Force motor had twin coils, and 90 degrees of coil separated by 90 degrees, and the polarities are such that when the coil is energized, you have a north pole, a south pole. On the bottom of that coil, you'll have a north pole and a south pole, and they flop back and forth. They flip. Now, that particular design arrangement is driven by this particular rotor. This rotor is actually out of the ZFM, and it was used for the torque test back about a month and a half ago. And you take a look at the rotor, you will note that there are 4 neos on it, equally spaced, 90 degrees apart, with the polarities facing each other. So north, north, south, south. Now with the Ron Cole design, there's a curveball. Let's see what that is. This rotor has only 2 neos on it, and they are essentially different polarities, south and north. Looking back at the motor, the polarities are wired again in series, but such that we have north, north, and then south, south on the bottom. And they constantly flip, north, south, north, south, north. So you have a fluctuating magnetic field, but again, it's north, north, and south, south. That's really the major difference between the Zero Force motor and the Ron Cole arrangement. Ron Cole was very influenced by John Bedini, of course. But let's take a look at what we're driving this entire system with. Now, you will note that we are driving the system now with this particular board. And its purpose in life is to provide the signal to switch things back and forth. In other words, flip the polarity of the fields. And this particular board, Zero Force motor drive, has a couple of LEDs on it, which are really convenient because they tell you how the firing circuit, the trigger circuit, is working. It also has, very conveniently, an on-off switch. So, we have those particular details now in mind. You will note also that we have this little device right here, and that is a TET amp sensor. This amp sensor is a Hall effect device, so the signal that goes through it as it's picked up is really an analog signal. There's no digital outputs involved, so you get a 4 to 20 output coming out of it that's extremely responsive to what's happening with the amperage. I like to look at the amperage because that to me is a measure of the energy, if you will, a portion of the energy flow within the motor itself. So I think we've hit those aspects, and now we are driving this with this particular device, and that is a Tech Power 60 volt, 10 amp linear power supply, and it's adjustable. It seems to be working fairly well after I had my batteries blow out. This seemed to fit the bill. Now, let's just give this a quick spin because I intend to do a more complete run with all the voltages that we normally run at. And what I will do here is just give you a short demonstration. More to come on that second video. So let's start this up. This is a different style motor, and it has some, most definitely has some quirks to it. So it'll probably speed up to about 6,800 RPM. And you will note the width of the amperage, how it's bouncing around. Never goes to zero, but it stays right up there. The overall amperage can be read both on screen here. I have it set up at about 30 samples per second, so that makes it relatively difficult to see what the heck is going on. However, on the power supply, there is a display. You see we're running at 35.94 at 0.72 amps, 36 volts. Let's just take a gander at the speed here. Let me adjust this in. So we're seeing about 6850 RPM, 6900. It vacillates back and forth. You'll note the vacillation on screen here. It like compresses itself and then flares out. Compresses itself and flares out. Very interesting. The motor seems to be fighting itself, or there's something else going on inside that really has been unexplored. Anyway, this is for show and tell, and just for kicks, we can see, I think, the LEDs here. They're showing you just a constant glow of yellow or amber and red. Well, I think that's it for this particular video. I did want to elaborate a bit, and there you go. Thank you for watching.